Hey everyone, and welcome. Today we're going to jump right into the heart of the AI revolution, large language models, or as you've probably heard them called, LLMs. These things are, no joke, completely changing the game.
Okay, so you've seen the headlines, right? You've probably messed around with the tools, but what's really going on behind the curtain? How does the magic trick actually work? Well, that's exactly what we're here to break down.
You know that feeling when you're chatting with something like ChatGPT and you just have to step back and go, wow? Well, if you've had that moment, then you've already shaken hands with an LLM. That very experience is what this is all about.
All right, let's get into it. We are living right in the middle of the LLM revolution. These models have been fed literally billions and billions of words. And because of that, it's getting harder and harder to tell the difference between human and machine language.
To get how this all works, we got to start super small. See, an AI doesn't read words like you and I do. It sees something called tokens. You can think of them as the fundamental building blocks, like Lego bricks or puzzle pieces for language that the machine uses to figure everything out.
So let's take a super simple example, the word apple. When the model first looks at it, it's just a bunch of letters. A-P-P-L-E. But it's been trained on so much text, it starts to see patterns. It learns that A-P-P-L-L show up together all the time. So it bundles them into one efficient token, apple. This is the very foundation of how it learns language.
So what does this mean in practice? Here's a quick and easy way to think about it. 100 tokens works out to be about 75 words. This is basically the currency in the world of AI. It's how they measure the size of everything, from your prompt to the final output. Okay, so the AI has its Lego blocks, the tokens. But how in the world does it put them together to make something that actually makes sense? Well, that's where the architecture comes in. This is the real engine of the machine.
This is where things get really cool. How does a machine know that king and queen are related, or that walked and walking are connected? It uses something called vector embeddings. Just picture this giant multidimensional map of meaning where every word is like a city. On this map, words that mean similar things are right next to each other. Virtue is a neighbor to moral. It's this relationship, this closeness on the map that helps the model understand context. But having a map is one thing. You need a conductor to make all the pieces play together in harmony. And that's where the transformer architecture comes in. This right here was the absolute game changer. It's like an orchestra conductor using a special trick called self-attention to make sure every single token in a sentence knows about every other token. That's how it gets grammar, nuance, and the whole context right. And believe me, once that original attention is all you need paper dropped from Google in 2017, things just exploded. The pace since then has been absolutely breathtaking. It led directly to the powerful models we have today, like GPT-4o, which can understand text, listen to audio, and see images all at the same time.
Now, this crazy pace of innovation isn't just happening by itself. It's a full-on race between some major heavy hitters, and each of them has a pretty different idea about how to build the future.
And if you look at the major players, you'll see a really interesting split. On one side, you've got companies like OpenAI and Google who are keeping their models closed source. But then you have Meta, which is pushing hard for an open source approach with its Llama models. And then there's Anthropic, which is kind of its own thing, building powerful models with a huge emphasis on safety.
Just to give you a sense of how powerful these things are, get this. OpenAI's GPT-4 took the Uniform Bar Exam, which is an insanely hard test for people who want to become lawyers, and it scored in the 90th percentile. I mean, that's a level of complex legal reasoning that was pure science fiction just a handful of years ago. And it's not just about reasoning, it's about sheer capacity. Take Anthropic's Claude 2 model. It has what's called a context window of 100,000 tokens. What does that actually mean? It means you could literally feed it the entire book, The Great Gatsby, for example, and then just have a normal, detailed conversation with it about the plot, the characters, anything you want all in one go. And that brings us right back to that big debate, open source versus closed source. With open source, anyone can build on it, which can lead to incredible innovation, but there's a risk it could be misused. Closed source gives a company way more control over safety, but it can also mean that research gets locked away. It's honestly one of the biggest questions the whole industry is wrestling with right now. So, okay, we've got this incredible power, this intense competition. Where is this train heading? The path forward is just as fascinating as the tech itself, and you better believe it. It comes with its own set of challenges.
You know, the future isn't just about making these models bigger and bigger. It's actually about making them smarter and smaller. We're seeing more specialized models that are fine-tuned for just one job. And new tricks like quantization are making it possible to shrink them down. Think about that for a second. The goal is to have an AI this powerful running right on your phone without needing the internet at all.
Okay, but as we all start using these tools more and more, we gotta be smart about it. A few really important things to remember. First, data privacy. Never, ever put sensitive personal information into these things. Second, remember these models learn from the internet, so they can absolutely pick up and repeat biases they find there. And finally, human oversight is still absolutely essential for making sure this technology is used ethically and responsibly.
And all of this leaves us with one last kind of mind-bending question to think about. As these AIs get better and better at the art of language, something we thought was uniquely human, will there be a day when they're actually better at it than we are? It's a question that really gets to the heart of what creativity even is. Something to chew on. Thanks so much for tuning in.